All right. So now let's look at some more problems. Okay. Like what we did in that last one. All right. Our basic idea was to take the complicated three-phase circuit and try to get it to a single-phase equivalent, really where everything was in a Y connection. Okay. We took it from here to here. All right. So let's say we had a situation where instead we had, let's say, a delta setup. Okay. All right. Let's look a little more carefully at this first. All right. If I want to get, and I said this at the beginning, if I want to go from a delta to a y, all right. So again, if I want to go from, I want to take the circuit, the complicated circuit, and try to get it to a single phase equivalent. If I have a delta setup, I usually want to do my delta to y conversion. All right, where the equivalent Y impedance is the delta impedance divided by 3. Okay, that's if it's balanced, which is usually what we want. All right, we've got to be a little bit careful though with deltas because let's look at this, what we talked about before. Line current is the current in a line, okay, here. All right, phase current is the current in a phase, and we said a phase is basically one of these impedance branches. All right, one of these three or one of these three. Here in the Y connection, the line current and phase current are the same. All right. Here, all right, they're not. All right. So how do we relate? Let's look specifically here. Okay. All right. Let's draw that situation a little bit more carefully. All right. Let's say I have this picture here. Okay. Let's draw the picture like this, same way that the book draws it. All right. So all right, Z delta, Z delta. Okay, so each of these, let's say, is the same impedance. Okay, all right, and let's call this point capital A, call this point capital C, call this point capital B. Okay, this current here is IAA. All right, it's coming from a source labeled with little a. This would be I little b big B, going that way, and I C C would be that current, little c big C. Now, I can then call these guys the phase currents. These are the phase currents because they're in each phase. These are the line currents because they're in the lines going to it. All right, IAB is from A to B. Okay, I'm going to say IBC is that phase current. And then my third one will be ICA. Okay. Now, let's at this case, I'm gonna make a definition. It's these currents. Okay, first of all, one thing we know about these currents: if these loads are balanced, okay, and if the sources were balanced, we know that the magnitude of IAB, IBC, and ICA is the same. Okay, so I'm going to say that IAB, I capital A, capital B, I'm going to say that has a magnitude I5 for phase. Okay, and I will say the same thing for BC and for ICA. And I know that they should each be 120 degrees out of phase with each other. So if this guy has an angle of 0, let's say he has an angle of negative 120, and he has an angle of negative 240, okay, or positive 120, however you want to look at it. All right, he is negative 120, All right, he is negative 240.